Hello and welcome to my channel. I am Akram and you are watching Knowledge 360. In the previous video, we had covered the topic of primary key constraints in PostgreSQL database. So in this video, we are going to cover foreign keys constraints in PostgreSQL database. So the first question is why foreign key is needed in PostgreSQL database or in any RDBMS database. So the simple thing is to maintain the data integrity between two tables, we use foreign key constraints. So to understand this, let's assume that you are trying to add one employee to a department that department doesn't exist at all in a company database. Suppose there are two departments, one is admin and the other one is HR department. But you are trying to add one employee to accounts department. So that is a wrong data and we should not be able to add such data. So to restrict this kind of scenario, we implement the foreign key constraint. So let's go by definition. A foreign key is a constraint that maintains referential integrity by linking records across two tables, and it requires the values in one table's column to match values in another table's column. This ensures that relationships between tables remain consistent. So let's see one basic example of a foreign key. So how do we define a foreign key in this case? So in our orders table, we need to create a column called product number, and the product number that should be referred to the product number of products table. Okay, so this is how we can match the valid product IDs. So let's create the table first. First we create the products table where product number is the primary key, and then we create the orders table. So in the orders table, if you see, we are creating the product number and that refers to the product number of the product table. So this is how we can create a foreign key constraint. Now let's insert some valid data into the products table. Then we insert data into the orders table. So data are inserted. How it was inserted? Because all the product number that we are inserting into the orders table, they all are existing in the products table. We are having the orders with product number 1, 2 and 3, and the 1, 2 and 3 products exist in the product table. Now if we try to insert an order with product number 5, so this should fail because there is no product with the product number 5. So this failed because of the foreign key constraint. Since we have implemented the foreign key constraint on the orders table, so this is impossible to create any order with not null value that doesn't match the product number in the product table. And yes, it is possible to insert the null value if we don't know the product number when we are creating the order, so we can pass the null value, but we cannot pass the any not null value which is not present in the product table. So here there are two tables. One table is called referencing table and the other one called is referenced table. So these two term we are going to use very frequently going forward. So referencing table in this case is the table with the foreign key, that is the orders table, and what is the referenced table? The table to which we are referencing. In this case it is the product table. Now let's see the foreign key constraints simplified syntax. So in the previous example, if you remember, we used to mention the table and also the column, to which column this should refer. But in the simplified syntax, we can omit that. We can simply write the references and then the product table, means the table to which we are trying to reference. So this way also we can create the foreign key constraint. This works in the way that whenever we write a table to refer, automatically the primary key is chosen to be referred, because we know in a table there can be only one primary key. So let's create the product table and then create the orders table, and let's insert the valid data, and then we try to insert the bad data that should not be inserted, and when we try to insert and it fails. In the previous two examples we saw that we can create the foreign keys by simplified syntax or by mentioning the column of the table, and also we can name the foreign key constraints. So we can give our custom name to the foreign key as well. So let's create the table called customers where the primary key is customer ID. Then we create the orders table. So if we try to insert the name to foreign key constraint, so this is the syntax. We need to mention the keyword constraint, then the name of the constraint, and then the keyword foreign key, and then the foreign key of the same table. This is the table orders and the column is customer ID, and then we need to mention the references customers and then the column. So let's create the orders table. The orders table is also created. Now let's insert some valid data into customers and orders table. Data are inserted. Now if I try to insert this data, this should fail because there is no customer ID with the customer ID 3. Okay, so we have customer ID 1 and 2 only. So this insertion is failed. So this is how we create a naming foreign key constraint. So in the next example, let's see how we can create a foreign key with multiple columns or a group of columns. And this is required when the reference table is having multiple column primary keys. That means a primary key is consisting of multiple columns. So let's see such example. For that, let's create a department table. And if you see, the department table primary key is consisting of two columns, department ID and location. So when we create a table employee, so when we try to refer to the department table, so obviously we need to refer to the both the columns, the combination of the columns. So let's create the employees table as well. So the employees table is also created, and here we created a foreign key with multiple columns. Now let's insert valid data. Valid data are inserted into departments table and employees table. Now if we try to insert this data, let's see. So this is going to fail because the department ID 3 and location New York doesn't exist. If you see, the department ID 3 is having the city name, the location name is as Chicago, not New York. So this is how we can implement the foreign key constraint with multiple columns. Now let's see an example of self-referential foreign keys constraint. So sometimes this is also required when we try to refer to the column of the same table. Okay, there are multiple examples of it. We can say, to understand this, let's create an employee table with the employee ID as primary key, and also we are mentioning the supervisor ID, which is also an employee's ID. Okay, so a supervisor can be an employee, so we are taking the employee ID as supervisor ID, and if you see, we are referencing the supervisor ID with the same table employees with employee ID. So this is called a self-referential foreign key constraint. So let's see the example of it. Now we create the table called employee and we insert some valid data. We have inserted. Now if we try to insert this data for employee ID 6 and we are trying to implement the supervisor ID is 10. So there is no employee with the employee ID 10. So this is going to fail. So let's see that. So this failed because we have implemented the self-referential constraint on the employees table. Also, we can create multiple foreign keys in one table, and multiple foreign keys allow to hold the many to many relationships. So let's see the example of it. First, we create the products table. The product table is created. Then we create the orders table. Now, when we try to create the order items table, if you see, we are trying to mention the product number and the order ID as well, and the quantity, how many quantity of product is included in a particular order. So when we create this, we are creating actually references of foreign keys. One is referencing to the products table and the other one is referencing to the orders table. So let's create this table, orders item. So the table is created. Now let's insert some valid data first. The valid data are inserted. Now if we try to insert this record, this is going to fail because the product number 4 doesn't exist. Let's verify that. So the product number 4 doesn't exist, so this is going to fail. So this failed, and that means we can create multiple foreign keys in a table. So till now we saw how we can implement the foreign key constraints to restrict the data. But what will happen when we try to delete the data or we try to update the data from the parent table? In this example that we saw, we can take the example of product table and we can take the example of order table as well. So what will happen when we try to delete the record from the product table with product ID 1, but we have data in the orders table with the product number 1. So how we can implement that, how we can restrict that, or how we can manage this process? So for that there are two major options. One is on delete option and the second is on update option. In case of on delete option, it will manage the data when we try to delete the data from parent table, and for on update option, it will manage the process when we try to update the data from the parent table. So let's first cover the options of on delete options. So there are three options. One is on delete restrict, and the second is on delete cascade, and the third is on delete set null or set default. So in case of on delete restrict, it prevents the deletion of a reference row if it has existing foreign key dependencies. Correct. So it will not allow to delete the data at all. And in the case of second cascade, on delete cascade, it will automatically delete the record from the child table as well. Suppose we have some data in the child table, so it will automatically remove that complete record as well. And in case of set null or set default, it sets the foreign key values to null, the child table value, or the default value that we mentioned. So we'll see all of them with one by one example. So first let's see on delete restrict and on delete cascade options. So for that let's create table called a category table. We have created the category table, then we create the table called the products table. But here if you see, we are mentioning that on delete restrict. So that means whenever we try to delete the data from the category table, if the value is used in the product table, so it will restrict us and it will not allow to delete the record. Also let's create the orders table. So when we create the order table, we are mentioning that on delete cascade. That means whenever we delete some product ID from the products table, so it will delete all the record of that product ID from the orders table as well. So to see that, let's first insert some valid data into all the tables, categories, products and orders table. So the data is inserted. Now we see try to delete the data from the category 1 table. So as we saw that it should restrict the data because we have implemented the on delete restrict option on this. So if I try to delete the particular data, so it restrict me and it is not allowing to delete the data. So what happens when we delete the product data with product ID 101? So we know what is going to happen. So it will remove all the data from the orders table with the product ID 101. So let's see that. So we have deleted 101 product ID. Now if I show you first the products, so there is no data with product ID 101 because we deleted them. Now if I show you the data from orders table, so if you see in the orders table we had inserted one data with product ID 101, but that doesn't exist anymore. Okay, in the next example let's see how on delete set null will work. In the on delete set null, it will set the foreign key value to the null. That means the child value will be set as null. So first let's create the tables. When we created the orders table, we have given the option of on delete set null for the category ID. That means when a category ID is deleted from the category table, the category ID value will be set as null on the orders table. So let's see that. First, let's insert the valid entries. Okay, data are inserted. Now let me try to delete the data from the categories table. Okay, the category ID with 2 is deleted. Now, if I see the data, so whatever orders were placed with the category ID 2 must be set as null. So, if you see the order ID 202 was set with the category ID 2 is set to null now. Now, let's see how set on delete set default works. It will, instead of setting the value to the null, it will set a default value. Okay, so for that, let's create the tables. So to implement that, when we write the order table creation, so we are mentioning the default value as 99 because this is the default value going to work, and on delete option we are giving as set default. So we create the table orders. Now let's insert some valid data are inserted. Now if I try to perform the same action, that means deleting the category ID 2. So what happens? Let's see. So in the previous example, the category ID was set to null, but this time the category ID is set to 99. That is 99 is the default value. If you see, when we created the orders table, we have mentioned the default value 99. But remember, the category ID 99 must exist in the category table. So if you see in the category ID table, a category with 99 is existing. Okay, after on delete options, now let's see how on update action works. So this is similar to on delete as well. On update can propagate the changes from referenced to referencing rows when the reference values are updated. That means the parent data are updated, so the changes will be reflected in the child table. So there are two options for on update action. One is on update cascade and another is on update set null. So in case of on update cascade, it doesn't propagate the changes for fields other than the reference column, and in the on update set null, it will only set the foreign key column in the referencing table to null if the reference key column is the parent table changes. Okay, so let's create the table to see the examples. First we create the category table, and then we create the products table, and here we mention the category ID as on update cascade, and also we create the table called order, and here we make the on update action as set null. Now let's insert some valid data. Now let's try to update the category ID 1 to 10. So what will happen? We'll see in the result set. So the data is updated. Now let's query it to the product table. So in the product table, if you see on update cascade is worked, and if you see the category ID 1 is changed to category ID as 10. So automatically the data in the child table has also updated. Now let's see on update set null option as well. We're trying to update the category ID 2 to set the category ID is 20 in the categories table. So let's see how it changes the data in the orders table. So in the orders table, all the category ID with value 2 has set to null now. So there are two keynotes here. On update cascade, it updates the foreign key values to match changes in the parent table primary key, so to maintain the data integrity throughout the tables. And in case of on update set null, it sets the foreign key values to null when the parent table primary key changes. And also on delete option and on update options help maintaining the data consistency in the RDBMS database. Now let's see how we can create indexes on foreign keys. While foreign keys don't automatically create indexes on referencing column, but indexing help improve the performance, especially for the large datasets. So in case of joining queries, when we have more than one table involved in the query, so the indexing is helpful to get the faster result. So first let's create the table called categories, and then we create the table called product, and the product table category ID is referencing to the category table. Now let's create the orders table. The orders table product ID is referencing to the product ID product table. Now let's create indexes on the category ID of product table. We know this is not a primary key on this table, and also we create one index on product ID of orders table. So we created two indexes. Now let's insert some valid data to the tables. Now let's try to query the data. So we saw the result as the data output. The index on the category ID in products table helps speed up the join operation in this case. And also let's check one more query. So in this case also index on product ID in the orders table, it helps in the faster data result. Okay, now let's see how we can drop a parent table in a foreign key implemented parent-child relationships. So let's see how we can do that. First, let's create the table parent table called department and the child table called employee. So in the child table, the department ID is referenced to the department table. Now let's insert some valid data. The data is inserted into the department table, and now let's insert data into the employees table. So the data are inserted. Now what will happen when we try to drop the table called department? So we know the department table values are referenced in the employees table. So how we can do that? So if I try to drop, it will restrict me and it will not allow to drop because we have data in the child table and the department ID is referenced to the other tables. So how we can implement that in that case? So we can implement department table drop including the cascade option. So let's try to drop the table with the cascade option. So when we try to drop the table with the cascade option, so what it does, it drops the foreign keys as well. So this was all about the foreign key constraints in PostgreSQL database. If the video was helpful, do like the video, and in the next video we'll see about system columns in PostgreSQL database and we'll see examples of them as well. So subscribe my channel to get the notifications for upcoming videos. Let's meet in the next video. Till then, take care. Bye bye.